Okay, so when we talk about parabolas, in this case, are quadratic functions. Quadratic functions are always going to graph as a parabola, and so they're either going to open up or they're going to open down. You also know, we should by now know the degree. So the degree of a quadratic function is what? How much is? You were about to say it.
No.
You weren't?
I
Oh,
got it.
I thought you said. What would the degree of any quadratic equation be? In other words, what's the highest power of exponent? 2. Yeah, it's a 2. I thought you were about to say 2. So you're right. So a quadratic equation is always going to have one of your variables be squared. Okay? If it's going to be the x squared, then it's going to open up and down. If it's going to be a y squared, it's going to go open left and right. And then, of course, it wouldn't be a function then. So thanks, Levon. You can just set that on my purple folder. So we also need to know that there's a couple of key points on a parabola. So either the highest point or the low point is true. It would be, but it also has another name for just parabolas. So it starts with a V. The vertex. The vertex. So in this case, this would be the vertex. Obviously, this is a parabola that opens downward. If I had a parabola that opens upward, let me just go ahead and move it up here, and I'll just kind of do this one. Then my vertex point is going to be the minimum value. This one, it obviously, since it's opening downward, it's going to be the maximum value. We'll also should be able to identify the x-intercepts and the y-intercepts. Remember, all x-intercepts, that's going to be the value when y equals 0. And when you have a y-intercept, that's going to be when x is equal to 0. And then we're going to also look at symmetry. Okay, so there's an axis of symmetry in every parabola. In other words, right down in the middle that goes right through the vertex, okay, is going to be an axis of symmetry. And so in this case, it's going to be, it'll always be, if it opens up and down, it's going to be your x value. Okay, I talked about before, if it's not a function and opens right and left, it's going to be your y value. But it would have it. And so on this case, it says find the domain and the range of the graph of the opening of, and the opening of the parabola. So in each of these, we're going to go ahead and find that. So let's go ahead. If we talk about the domain and we have a function of a quadratic, your domain will always be, yes, domain will always be from negative infinity to infinity, because you're going to say, I'm going to be able to go as many points as I can left and right, and I have no restrictions on my x value. But my range is going to have some restrictions. So my range, it's only going to go, in this case, if it opens downward, it's only going to have a maximum height. And so it's only going to go up to 4 in this case. So remember, we start with the lowest value, so you're going to go from negative infinity all the way until you get to 4. Will it include 4?
Yeah.
Yeah. So that means I've got to put a bracket there. And that would be the domain and range of those functions. Now we're gonna continue finding. Like if I ask on this one, let's go ahead and for the parabola that I have before, if I have the vertex point is going to be this point right here, which is going to be the very maximum value. So it's going to be located at 1, 4. I have the x-intercepts, so that means y is going to be 0, so it's where it's crossing the y-axis. So it's going to be at, since I'm looking for x-intercepts, I'm going to say it's going to be -1 and 3. And I'm not going to put a comma there because then it looks kind of like a coordinate, the -3, 1. Remember, I would accept all subcoordinate points. So in other words, you could go -1, 0 and 3, 0. I would still accept that as one of my answers. I think in your book, when you do your homework, it's like there are blanks there, and you just put the value. And then the y-intercept in this case, where it crosses my y-axis, remember x is going to be 0, so it's going to be, in this case, it's going to be 3. Or you could also say, again, the point 0, 3. I would accept either one of those. Now my axis of symmetry is going to be the line that goes directly down the middle that makes it symmetric on both the sides. So in this case, it'll always be your x value, so it's going to be then x is going to equal then 1. So you would need to write it as an equation. In this case, it'll be x equals 1. Now, when I do a quadratic formula, there's also a way you can put it in like an equation. So the standard form of a quadratic equation is f of x is equal to a times the expression x minus h expression squared plus k. And this is where you can identify the vertex easily because the vertex will be located at h comma k. Remember, it's going to be the opposite. So when we put things inside the function like x minus, it'll always look like the opposite. So if I had an x plus 2, my vertex, the x value of my vertex would be a negative 2. If it's going to be an x minus 4, it would be at 4. So it's always going to look like the opposite of your x value, but your y value is just plus k. So whatever it is, this is going to be your up and down, so the y value will stay the same value. So when I look at this one right here, it's already in the form of my standard form where a is going to happen to be equal to 0, but my vertex in this one, my x value would be, in this case, 3. And my y value would be then 2. So my vertex is going to be 3 comma 2. Now what happens on this, it says graph, we're gonna give the equation this x is a symmetry. So let's just go ahead and start by graphing it. So I'm going to go over 1, 2, 3 and come up 2. I need to determine whether it's going to open up or down, and that's going to be the value of a. So in this case, it gives you directions. If a is going to be greater than 0, okay, so it's larger than, it's not a negative number, it's a positive number, then it's going to open up. If a is going to be less than 0, like it's a negative number, it's going to open down. And so in this case, a is going to equal 1 because there's an assumed 1 right here. This could be written as 1 times x minus 3 expression squared plus 2, but we just wouldn't really need it. So a is going to equal 1. That tells me that it's going to open upward. Now, an easy way to do that, when a is equal to 1, from your vertex point, if you go over 1, you can also come up 1 because it's going to be that same. Now remember, it's not going to continue that way because that would give me the absolute value kind of equation. It's not a straight line. It's actually a curved line. But to get this point here, you can go over 1, up 1, and back 1 and up 1 and get those points. Remember, if it was 2, you would go over 1 and up 2, back 1 and up 2. Same thing, like if it was a half, you could do the same thing. You'd go over 1 and go up a half. And so when I graph that, then I can go ahead and just kind of fill that in the best I can. And then I'm also going to determine the axis of symmetry. Well, the axis of symmetry is going to be right down the middle. Maybe I should put it in like a highlighter color. So it's going to be right down the middle, and it'll also be the x value of your vertex. So if my x value has happened to be 3, that means my axis of symmetry will also be x equals 3. Then we're going to also determine the domain and the range. Now we said earlier, obviously, the domain is going to be? Yeah, negative infinity to infinity. You're going to find that on all of these that are, since it's a function, it's not going to be opening left and right, and therefore it's always going to have a domain that's going to be negative infinity to infinity if it's a quadratic. But my range will not be. Okay, so my lowest value is going to be what value? 2. But then I'm going to go all the way to infinity, so I'm going to go from 2 to infinity. I know I always put a parentheses with infinity, but it includes 2, so I need to make sure I put a bracket. Questions on that? Perfect. Now, I'd like you to, I don't know, put a star by this one, because this is a formula that I'd really like us to utilize more, because I've been trying to do an activity where we actually do some motion. When we like project, when I throw a ball, and it has gravity acting on it, and it's pulling down, it actually, the line that the ball would, the path that it would make, makes a parabola. And so knowing that the x value is also can be easily found from any quadratic with minus b over 2a, then it makes it easy for us to find the vertex point, okay? And then what we do then, that says the vertex is going to be, the y value is f of a minus b over 2a. Well, what that means then is just that we're going to substitute that x value back into my equation. So let's say we have the equation here. I still like to write, when I have f of x, I would write it as my quadratic first. So I would start with a negative x squared minus 4x plus 5, because then that's in the form of ax squared plus bx plus c. All right, and then then I can identify a is going to equal a negative 1, b would be equal to a negative 4, and then c is going to equal 5. And by doing that, if I'm looking for then my x value of my vertex, I'm going to go ahead and say, well, x is going to equal a negative b over 2a. And so then I need to just substitute those values in. So I'm going to put negative 4 in for b. So I'm going to have a minus 4. I could put that in parentheses, that would help, over 2 times a, which is going to be a negative. Well, these together, the minus of minus 4 changes it to positive 4, but then I have it over a negative 2. So 4 divided by a negative 2 would be then a negative 2. So I know that the x value of my vertex is going to be then just negative 2. To find my y value, then I want to find f of negative 2. And that's really what this is saying. It's just, I think sometimes it looks a little more complicated than it really is. All you're doing is substituting the x value right in for your x, and we're going to find f of negative 2. So I'm going to put it in minus, and I'm going to have a negative 2 expression squared, minus 4 times a negative 2 plus 5. And so in this case, I'm going to have negative 2 squared, which is going to be 4, so I'm going to have minus 4. But I have a minus 4 times a minus 2, and that's going to be plus 8. And then I'm going to have plus 5. And so in this case, I have negative 4 plus 8, which is 4, plus 5, which is then going to be 9. So my y value then is going to be 9. And that tells me my vertex is going to be then at the x value of negative 2, 9. So I'm going to go ahead and mark that. Negative 2, I'm going to come up 1, 2, 3, 4, 5, 6, 7, 8, 9. Well, what we just talked about before on the last parabola was that if the value of a is negative, it's going to open what direction? Down. And if it's going to, in this case, it's a negative 1, so I know that I'm going to go down 1 and over 1, and, down 1 and back 1. Okay, so I know I have that amount. And then I'm going to go ahead and I can go ahead and I have enough that I can just draw my parabola. Okay, I could also find, in this case, my y-intercepts. Okay, give the equation of, we need the axis of symmetry, so let me go axis of symmetry, that's the abbreviation for that. So it's going to be, remember the x value, so it'll be x equals negative 2, good. And then on this one, I'm going to go ahead and I'm going to do the domain and the range. So I could also find where it crosses the x-axis, but let's just go ahead and, I think they only ask for the domain and the range. So in this case, my domain, remember it's going to be negative infinity to infinity on all of these, but my range, it's going to, my lowest value is going to start as what? Good. Negative infinity to 9. And then it's going to be parentheses and then a bracket with the 9. Any questions on that? Okay. Then the next one. So we're going to have some problems, and I'm going to do the next one. The first one we do a common one where it's going to be, we're going to have 200 feet enclosed, a rectangular plot that borders a river. And if you do not fence the side of the river, find the length and the width of the plot with a maximum area and what is the largest area that can be enclosed. This is a good problem because what we're going to do is we're kind of given some information about a perimeter, right, with the 200 feet. That would be your fence. But we want to know how we can rearrange that rectangle so that it has the maximum area. An area we would find by length times width. So when I do this, I'm going to draw a little river. Okay, see, I know I'm not the best artist here, but that's my river. And then I'm going to have my fence drawn. Okay, so I'm going to go ahead and make this be my width, and this is going to be my length. And in this case, I can't use the standard perimeter formula because I don't have two links. But I would have two widths. So perimeter is going to equal 2 times my width plus just one of my links because I have that river. And I also know that it's going to be only 200 feet long. So this perimeter then can change then to 200 is going to equal 2 times W plus length. I also am asked to find something about the area. And now in this case, my area is going to equal then length times width. And I want to know where that's going to be a max. So if I kind of think in terms of I'm graphing it, I'm going to have a parabola that's going to be opening downward, and I'm going to have a maximum value that I'm going to have, that I'm going to look for. And that maximum value is also going to be the vertex of my parabola. So in this case, I'm going to go ahead and solve, because I have two variables here. I'm going to go ahead and let this be my f of w, because I'm going to actually put a function in terms of w, and I'm going to solve this one for L. And I'm going to replace my L then in my equation. So if I do that, then L is going to equal 200 minus 2W, correct? Just by simplifying. But then I'm going to substitute it right here for my L, and now I have 200 minus 2W times my W. And now I can find my width. And so again, I'm going to distribute that in, so I'm going to have 200W minus 2W squared. Well, now on this one, I'm going to go ahead, remember the ax squared plus bx plus c, I need to find my vertex. So I have a minus 2w squared plus 200w plus c, which is going to be just basically 0. So if I find my x value of my vertex, then I'm going to go a minus b, let me go ahead and write the formula, minus b over 2a, and I'm going to see if I can move this up just a little bit so I can see it a little better. And so that means I'm going to substitute, I'm going to have a minus 200 over 2 times a negative 2. No problem so far? Or does that make sense? Uh-oh, kind of. Work with me on this. So the a is going to be here because it's with the w squared. It's going to be my term squared. So this is going to be, a is going to equal negative 2 to this. B is going to equal then 200. And then I'm going to substitute, I'm finding the x value of my vertex by using the minus b over 2a. So then I'm going to simplify it. So I'm going to end up with a minus 200 divided by a negative 4, and that's going to end up being 50. Okay? Now to find the other one, all I need to do, I can substitute it back into this equation if I want, or I can go back into my f of x here where I substitute w into that. And I did kind of change. I see where you may see. So this, remember the x value, I'm representing a function in terms of w, so x is going to be the w value. Did that throw you off? So in this case then my width is going to be equals 50. My length would be then 200 minus 2 times 50, and 2 times 50 was going to be would be 100, and 200 minus 100 would be then 100, and then I would have then the feet. Is it feet? Yes, sorry, I was trying to remember. I've been doing. So I have my dimensions of my rectangle needs to be 100 feet by 50 feet. Does that make sense? Kind of? As clear as mud? We will do another one on Thursday where it's going to be where we have like a projectile, because that one will also be kind of one that I want you to understand. So I'm going to go ahead and quit. Short lesson today.